Hey, hello everybody. We've got a full house. Thank you all for coming, and welcome to this talk about Project Tango and aerial learning. So my name is Wim Joersen, and I lead the Project Tango location team. So today I will talk about aerial learning, which is one of the core technologies of Project Tango, and it's at the foundation of almost everything we're working on in my team. So it's something I really deeply care about, and it's exciting that today I could spend a whole session on aerial learning. And if you have no idea what aerial learning is, that's okay, we'll cover that in this talk. So let's get started with an overview of the key things that you will learn in this talk. So number one, by the end of this talk, you will be able to build an augmented reality application where you can put virtual objects in the world and they will stay in place. Like they will not drift away. So if you have built AR applications before, you know this is a really big deal. And I'll have a live demo where I'll show you how I place these objects and how they kind of stay in place in the environment. Number two, by the end of this session, you will know how to build multiplayer experiences where multiple Tango devices interact with each other. And this is obviously without any wiring, without any infrastructure in your environment. It just works with just your mobile device. And then finally, we'll talk about some future applications where you could imagine that you just never get lost anymore in large buildings. So I always like to start out with a quick poll to get a little more background about you. So by raise of hands, like how many of you have heard about Project Tango before today? All right, that's most people. How many people know about aerial learning? That's just a handful. And how many of you are here because it's just really hot outside? Just a few honest people. All right. So today, I really want you to come away with a really good understanding of what aerial learning is, like how it works, and also how you can use aerial learning to build like new applications and enable new user experiences. So I'll start out with a quick high-level overview of what Project Tango is, for those of you who are still new to Tango. So fundamentally, Tango is about enabling mobile devices to understand the world around them. So Tango uses computer vision for your device to understand the geometry of the world, but also to know its own position and orientation in that world. So in some sense, it turns your screen into an extension of the real world. Like your screen becomes this magic window into the real world. And if you look at the example here, so think about this device, if it understands what the world around it looks like, and it knows where it is in that world, it can start displaying some really interesting content about the world. Like you could imagine you can display directions on how to get from A to B, or you could display like virtual furniture in your house, and you can go look at it from all different angles to see how it would fit. Or you can imagine you can have a game that just plays out right in your living room. So Tango can enable a whole new range of applications that just simply weren't possible before. So let's look at the three main technologies of Project Tango. So there's motion tracking, depth perception, and aerial learning. And if you've attended talks about Tango before, you've probably heard a lot about those first two. And today, we'll mostly focus on the third one, on aerial learning. But let's do a quick overview for all three of them. So motion tracking is all about allowing your device to know like, how it moves through the world. So as a developer, you can use motion tracking to know how your device moved relative to where it started. So if, for example, I start here and I move 1 meter, I can ask the motion tracking component, how far did you move relative to where you started? If I move back to my original place, I can ask motion tracking where I am, and it will tell me that I'm back where I started. So motion tracking is all about allowing developers to ask the device how it's moving through space. Then depth perception. So every Tango-enabled device, or every Tango phone, has a special 3D camera. So with this 3D camera, the Tango device can sense the 3D geometry of the world around it. So if I point my device at the speaker desk here, it could sense kind of this geometry of the front of the desk. If I point it at the back of the desk, it would sense the geometry of the back of the desk. So wherever I point it, it can sense the 3D geometry. And as a developer, you can query that 3D information in the form of 3D point clouds. So then the last core technology, area learning, this is what really gives your Tango device a memory. And it works in a very similar way to how people operate in the real world. So remember when you came into this dome or tent thing, probably in the back of your head you started building up a model of like what this space looked like. Like you saw a speaker desk, there's 2 big screens, there's a lot of chairs, and you take that mental model and you store it in your memory. So imagine now if you would leave the room, let's say you go to the restroom, and when you come back later, you would quickly recognize that you're in the same space, because you recognize the desk and the screens and the chairs. So you would recognize that you're back in that same space. And Tango area learning works in a very similar way. So when you bring a Tango device into a new space, it will use its camera to look at the world and compute this mathematical description of what the world looks like. And it'll store that mathematical description in its memory. And when you then bring that same Tango device in the same room at a later time, it'll be able to compare what it sees with its camera to that mathematical description it's stored in memory. And when those two match up, it recognizes space and it knows exactly where it is in that space. So let's dive a little deeper into the details of how area learning works and even how Tango works under the hood. So Tango has this wide-angle camera that it uses to look at the world. So it's much like in this example, when you're visiting a mall, your Tango device will look at a few key landmarks that it sees in the world. So for example, here on your left side, you see that vending machine. In front of you, there's some restrooms, and then there's another landmark like on top of the roof. So now what happens when you start moving in this environment, and you keep looking at those same landmarks, what happens is you see those landmarks all of a sudden in different places in your field of view. So if you, for example, look at that vending machine, initially it was on your left side, and as you move, at the end, the vending machine is almost right in front of you. And this is exactly how Tango motion tracking works. Like, Tango will look at all these landmarks in the world and see how they move as a device moves. And based on that motion, it can compute its own motion in space. So this is pure motion tracking, so this is still all without any memory. So in this example, if you're in the mall, if you would cover your eyes, spin around, and open your eyes again, you would have no idea where you are, because you didn't have any memory of that space. And the same, every time you start Tango motion tracking, it doesn't have any memory, so it always starts from scratch. So let's now think about, what if we add memory to this? So for a Tango device, it doesn't need to remember the entire image of what it sees. It only needs to remember those key landmarks that it's tracking. So in this case, it would look at a small square patch, like the little yellow squares, around each landmark to store kind of a mathematical description of what exactly that landmark looks like. So your Tango device doesn't care about the rest of the image, it just looks at those landmarks. So Tango will store 2 things in its memory. One is where it saw that landmark, and the second is that mathematical description of what that landmark looks like. And this is how Tango can remember a space. So let's jump to a live demo so you can actually see how this works under the hood. So I'll first just start up Tango motion tracking. So here, if you look at the left side of the screen, you get to see how Tango is looking at the world. You get to see yourself if you wanted to. And all those dots on the screen, those are the landmarks that Tango is seeing and that Tango is tracking. So instead of just looking at like 2 or 3 or 4 points in the world, Tango can look at 100 points at the same time. And as I move, Tango keeps track of how all those landmarks kind of move in the image. If you then look at the right-hand side of the screen, it's kind of a top-down view of where I am. So if I walk in a big circle here, you can see that motion tracking knows exactly that I walked in that circle and that I ended up back where I started. So this is motion tracking under the hood. So let's now jump to area learning. So initially this looks very similar. You just have Tango looking out into the world. But now Tango is actually building up a memory of what the space looks like. And once it has created a memory, so that has happened now, you see all these static yellow dots. Those are the landmarks that Tango has remembered. So I can go look at them from all different angles. They're literally physical points in the world that Tango has stored in his memory. And on the right-hand side, you see these lines coming out of the device. That is showing where Tango recognizes a landmark that's stored in his memory. So now we can do something really cool. So let's say I cover the cameras here. So my device has no idea where it is. And I'll just go hide it somewhere else. So now it should be completely lost. But if I point it back at the area that it learned, you can see all those landmarks popped back into place. So it actually remembered where it was based on that memory. So let me just do that one more time. So now it doesn't know where it is. And then you see jump, and all the yellow dots are back in place. So, yeah, it's pretty cool, right? So this is really a view under the hood of how Tango operates for both motion tracking and for area learning. So now, let's look a little bit at how we can use area learning. So you have a pretty good understanding of how it works, but let's see, what can it do for you? Like, what kind of new experiences can area learning enable? And let's first cover kind of an AR example. So let's say you want to put a virtual chair in your dining room. You want to see how it fits. The problem you're having here is that that chair will start drifting over time. And that is because if you just have motion tracking, you'll have very small errors that slowly accumulate over time. And if you walk around enough, your chair might look something like this. So it'll like slowly drift and drift and drift. So this is exactly the problem that we want to solve with area learning. So you want your chair to go back right there. So the way area learning can help here is it can build up a memory of where you placed that chair in the world. So it can remember where exactly you placed that chair. So even though if motion tracking slowly drifts, because Tango remembers where you place a chair, it can always correct it and put the chair right back in the right place. And I'll have a live demo of this coming up a little later. So it's actually pretty cool to see. So there's obviously a number of other AR-based examples. Like, let's say you're using the 3D sensor to start measuring the geometry of your world. If you have these like nice yellow annotations on your world, you want them to stay exactly in the right place. You don't want them to start drifting around. So this is, again, where area learning can help. And even if you have an example where your objects aren't static, like, for example, you have these monsters running around, you still do care that your virtual world and your real world stay aligned with each other. Because if you would start drifting, at some point your monsters would start running through the shelves, and you really want them to stay in the center aisle. So even here, with moving objects, you do care about that alignment. So again, area learning can help here. And now let's jump to the second kind of big use case, and that is multiplayer experiences. So the problem here is pretty obvious. You want to know where all the other players are in the world. And it would be awesome if you can do it without needing to put in cables or infrastructure in your environment. So how can area learning help here? So the key for multiplayer experiences is to have a memory of your space and to share that memory between all the devices. So when all your devices have the same memory, so here, this is the display of what your device could have memorized. If all your devices share that memory, they could all start recognizing where they are in that space. And in some sense, you turn the real world in your kind of way to tie all these Tango devices together. Like, you don't need any special infrastructure. Like, you're using your couch and your carpet and the poster on the wall, and they literally tie together this multiplayer experience. So let's look a little bit at how this actually turns out in the real world. Because the real world is always a little more messy. So I'll give a number of examples where Tango will have some challenges with area learning. And it will give you a bit of a better understanding of kind of where to best apply area learning. So if you look at these two images here, so the left side could be what your room usually looks like. And on the right is probably what you want your room to look like. And if you and me look at these images, we can kind of recognize that it's probably the same room. You see there's maybe the same shelves, there's some hangers that you recognize. So pretty sure, same place. But for a Tango device, those look like two completely different spaces. Because Tango has built up all these landmarks on top of the clothes and everywhere. If all the clothes move, all these landmarks have moved, and Tango would get confused. So it's kind of like, imagine you're walking around in San Francisco, and you're looking at some of the big skyscrapers to kind of keep yourself oriented. And then someone comes in and moves all the skyscrapers around. You'd be pretty lost. So this is really what happens to Tango when stuff in the environment moves a lot. So here's an example where things didn't move, but one image was taken in the day and one at night. So even though your landmarks are in the same place, they could actually look differently because of the lighting and because of shadows. And something that everyone that's played with cameras will probably recognize, if you have a dark room and a really bright window, you have troubles with your exposure. You either need to tune it on the window or on the room, but you cannot have it both ways. And this should be pretty obvious. If you have large crowds, they can make a space look very differently. And then another kind of extreme example, like Tango looks for visually interesting things in the world. And if your room is all white or like all one color, there's nothing visually interesting. There's no landmarks for Tango to recognize. So that will be a challenging space. And if you go outside, you can imagine a lot more different changes, seasons, weather, sunshine, shadows. So outside gets a little more challenging. So the question now is, how do you deal with all these challenges? And the key point here is time. Like, if you look at a lot of these changes that we talked about, those happen slowly over time. And some environments will change quickly, and some will change very slowly. Like, you could imagine a museum that has the same exhibition year-round, and maybe it has very constant lighting. There, your memory will be good for months and months at a time. And at the other extreme of the scale, you could imagine a subway station with lots of people running around. Maybe there's advertisements that change. So there, your memory would be valid for a lot shorter of a time. So a really good strategy to deal with this is to build your applications relying on a short-term memory. So if you think about your AR application where you want to show virtual furniture in your house, maybe you want to look at it for like 20, 30 minutes, but then during those 30 minutes, your house is not going to change, so you're good there. Or if you want to play a multiplayer game in your living room, maybe you want to play for a couple of hours, but during that time, your living room is still going to be your living room. So if you rely on shorter-term memory, like area learning could be a very powerful and reliable tool. So let's get to the, let's actually play this video. So this is a real-world example of area learning being used. So this video was recorded in the Zurich train station. And if you look at the video, you can see a lot of the challenges that we just talked about. There's some outdoors, there's some shadows that you see, there's people walking around. You can see the floors are kind of one color. But then still, area learning can actually work in this environment. So area learning can be pretty robust to a number of these changes. It's just the examples I showed were kind of extreme to kind of drive the point home. But you can see how it actually operates in the real world. And I'll go a little further in this video because there's actually something cool that maybe isn't always obvious. Because Tango fully works in 3D, you can actually go downstairs and it'll tell you in full 3 dimensions where you are in the world. So let's look a little bit at how to build an application with area learning. And again, I'll cover 2 examples. I'll have the AR example with drift correction, and I'll have the multiplayer example. So first one, so you want to use memory here to keep all your virtual objects exactly in the same place. So this is kind of where area learning will help you build this. And for this example, I will assume you already have an application that uses area learning. If you have an application that uses AR, and I'll tell you how to transition it to area learning. If you don't yet know how to build an AR application, Friday morning, Eitan Marder-Epson has a really interesting talk about how to build a full AR end-to-end example using Tango. So if you're interested in that, definitely go check out this talk. So, but here I will assume you have your application already, and we're going to port it to move to area learning. And the point of this slide is just to show you it is really easy. You need to change literally 2 lines of code. In the first highlighted line, you just tell Tango, please enable drift correction. In the second line, you will tell Tango, instead of measuring where your device is relative to where you started, measure it relative to this memory that will build up. With just those 2 lines, you can transition an app from regular AR to area learning AR. And let me show you a demo of how that works. So I'll show the same app first without area learning, and then with area learning. So this is a little AR app that allows me to place a really large cube on top of things. So, we are not using area learning, but the cube is pretty, it stays in place pretty reasonably well. But now if I'm a little more mean and I move around, you can see it's still more or less there. And if I do it a little more extreme, at some point I will lose my cube, because it just doesn't remember anymore where it is. So let's now do the exact same thing, but with area learning enabled. So now in the background, Tango is actually building up that memory of what this speaker desk looks like. So now, let me place the cube back. So now we can do the same thing. I can shake the device. And if I look back, as soon as it recognizes the space, it can put the cube back exactly in the right place. I can do my previous example where I cover the camera, let the app get completely lost, and then when I open it back, as soon as it recognizes it, it can put the cube back in exactly the right place. So you can have applications where your virtual objects will stay where they are. even if your session breaks, even if your user does something crazy, your virtual objects will stay in the same place. So let's jump to the next example. How do we build a multiplayer game? So this is a little bit more involved. It includes 3 different steps. So first, we will create a memory of, let's say, your living room. Then we will share that memory with all the devices, and then you play your game. So let's first think about how do you create that memory. So what that means, in your shared space, you want to build up literally this memory of what that space looks like. So how do you do that in code in Tango? Very simple. You tell Tango, start learning the area. And then when you're done, you say save. And then you have built up a memory of what that space looks like. So now, how to share that memory between your different devices. Again, pretty simple. Tango has an export and an import functionality. So you can export your memory from one device and import it on all the other devices. So once you have all your devices set up, you're ready to go play. So what area learning has done, or what that building up that memory has done, is created this one reference frame that can be used by all the different devices. Because that entire memory is all referenced from like one frame in your environment. So every single device in your multiplayer game can directly ask Tango, where am I relative to this memory? And if you have multiple devices using the same memory, they will all get their reference relative to that same reference frame. And this is how you run that in Tango code. You just tell Tango, please use this memory, and then you start asking Tango, where are you relative to this memory? So the code all looks pretty simple. So now I wanted to share a video, but I want to introduce the video a little, because I think it's easy to kind of underappreciate the awesomeness of the video. So the setting is exactly this picture here. So we have 3 players that have a Tango device in front of their face. So they are completely in a virtual world. They cannot see each other. And the video you're going to see is showing that virtual world of what one of the players is seeing. And one of the key things you should look out for, in that video, you will see a Tango device. And that, obviously, it's a virtual Tango device because it's a virtual world. But that device is actually exactly a match on a real device that's in the real world. And you'll see different players hand that device to each other. So think about it, how awesome that is. The players can only see their virtual world. So only if they know exactly where all the other players are, and they know exactly where that device is, only then can they do this comfortable handoff. So it's pretty amazing. So check it out. So this is filmed from the third person, so even the third person is moving around. And you see how the other 2 are just casually handing off the Tango device from one to the other. So this is only possible with registration between all those different components. So you have 2 players, you have the person filming it, and then the Tango device. You have 4 different devices tightly coordinated with each other. So pretty amazing. And then this is an example of kind of using VR. But if you want to try something like this for yourself, tomorrow night in the Project Tango After Hours, we have an AR multiplayer game set up. So you can go try it out. Also, if you want to just try Tango demos, the sandbox is there for the whole 3 days, so go test it out. We have a lot of cool stuff going on. Now that I'm advertising a number of things, there's 2 more Tango talks coming up. So tomorrow at 3 p.m., Johnny Lee will be talking about everything that's new within Tango. So definitely go check that out. And then on Friday morning, Eitan will be talking about how to build an AR application. So 2 more exciting talks coming up. So what's next for Tango, and what's next for area learning? What's coming up? So I hope by seeing the demos, you've been wondering, like, when can I try this? And today I'm excited to announce that everything you've seen until now will be part of our release coming out next month. So yeah. So you'll be able to build these drift-free, or drift-corrected AR experiences, and you'll be able to build multiplayer experiences. And this release is just the beginning for area learning. Like, the Tango team will keep improving and will keep building better and more robust algorithms. So this is just the very beginning. And as developers, you're getting a very early preview in what area learning can do. So this is the start of what will become a pretty exciting journey. So let's take a look at where this journey could take us next. Let's look a little bit at future applications. So here, imagine you're visiting a mall, and you're trying to figure out where you are in that mall. So you pop out your phone, you start up Google Maps, and then you get to see something like the image on the left. So you get a really nice floor plan of the mall, and then you see this big blue circle that tells you you're somewhere here, but we don't quite know exactly where. So now imagine what you could do with area learning. So imagine if your device could recognize exactly where it is in that mall. Like, you could pinpoint your location, and your experience could look a lot like the image on the right side, where you have an exact location, you even know exactly which direction you're facing. And if you take this one step further, if you combine that very accurate location with augmented reality, you can imagine that you can get really accurate directions on how to get from where you are to, let's say, your favorite store in the mall. All augmented in the real world. So I guess I hope this gives you some idea of where area learning can take us in the future. And that you realize we're just at the very beginning of what this technology can do. And then, obviously, we're not only at the very beginning of technologies like area learning, we're also at the very beginning of the Tango device ecosystem. So you've all seen the Yellowstone devices, which is our developer kit. There's thousands of those in the hands of developers out in the world. Now, Tango has partnered up with Lenovo. So Lenovo will be releasing the first consumer-facing Tango-enabled phone. And will be coming out later this year as a worldwide launch. So I hope, I want to end with this. I hope you realize this is actually a really great and amazing time to kind of be part of Tango and be a Tango developer. We have a lot of new technologies coming out. There's new devices coming out, and I think we really have this unique opportunity to redefine how people interact with their phones, and even how phones interact with the world. So I'm pretty excited to see what we can build together. Cool, thank you.